All right. Welcome to Kinetics. This is starting of Unit 9. It's not a long unit, but it gets a little bit tedious after a bit. So hang in there. We're doing this together. The work that is due today at 11:59. We have questions for the kinetics reading. Make sure you read this. This video this video kind of summarizes that up. We have lesson 4 classwork, which is on Test Wizard. You get 5 questions that test your knowledge on the stuff that you should have read, and then you have a pop quiz that's making sure that you've read the question. Pop quiz is only one question. I just want to hear your explanation and your concept behind that explanation. Um, Once again, make sure that you are doing your assignments. I know that this is a new avenue for us. However, if we target it and we put ourselves on an actual schedule, we should be able to handle it fine. If some of you are getting overwhelmed or a little bit tired, stick in there. Talk to us. I am here. I'm available through Pupil Pass, Google Classroom, and Remind if you just need to have a chat. And if you have any questions or issues, just let me know. I'm here to help you, okay? We're doing this together. So, like I said, intro to kinetics. Now, first, before we can even talk about intro to kinetics, we need to know what it means. So, kinetics is the study of rate or speed at which the reaction occurs. So, when we are studying kinetics, we're actually finding out how fast the reaction occurs. Now, for a reaction to occur, we must have collision. For a reaction to occur, we must have collision. I'm going to say this again. For a reaction to occur, we must have particles colliding. And when they collide, they must collide with the right energy and the right orientation slash direction slash alignment. Meaning, they have to the particles must hit each other with the right force and going in the complete equal direction or orientation. If not, a reaction will not occur. So for us to have effective collisions, we must have the right amount of energy and the right orientation. Now, there are a couple of factors that will affect the rate or the speed of a reaction, right? So anytime you see rate, it's really talking about speed. There are a couple of factors that might affect how fast a reaction will happen. So we're going to go over those factors and how they will affect the rate of reaction or the speed of the reaction. But remember, for a reaction to happen, we must have collision. So all these factors are going to cause more collision or less collision. So let's get started. The nature of the reactants. This is one factor that will affect the rate or the speed of a reaction. Now, ionic substances will react faster because they have less bonds to break. Covalent substances will react slower because they have more bonds to break. Now, just a quick review for ionic and covalent for those of us that are going to be a little bit confused with those words. Ionic compound is it's a bond or it's a compound between a metal and a nonmetal where the valence electron is transferred. With the covalent compound, that is a nonmetal and a nonmetal sharing valence electrons. So because covalents are sharing their electrons, it's going to be harder. There's more bonds to break. However, with ionic, because they're transferring, that bond is easier to break. So ionic substances will always react faster than covalent substances. Concentration. By increasing the concentration, we are increasing the reaction rate. We're increasing the speed of the reaction. Why? Because the more particles we put in a space means there's less space, making sure that our particles are colliding. I like to use this example. If we are in a subway cart, right, and you have 6 people, the likelihood of them colliding into each other is slim to none. But if we add a whole lot more people, the likelihood of them colliding to each other is so much greater because now there's less space. So the more particles you have, the more collisions you're going to have, and you're going to increase your reaction. You're going to increase your reaction rate, meaning your reaction will happen faster. So we have pressure. The third one is pressure. And remember, pressure only affects gases. Pressure only affects gases. If we increase the pressure, we're increasing our reaction rate. Because what happens is when we increase the pressure, we are taking away volume, and that's causing less space, which is also causing more collisions. Once we have more collisions, we have more we have a faster reaction, thus increasing our reaction rate. Right? I like to compare this to a can of soda. If you leave a can of soda, don't touch it, right? It's going to be perfectly fine. But if you have a can of soda, right, and you increase that pressure by shaking it, there's so much less space that if you open it, it might just shoot out. Because there's less space when you shook it, the molecules are causing each other to collide. And once they collide more, you're going to get a faster reaction. At the end of the day, we want more collisions. Temperature. This you guys have experienced already. So when we increase the temperature, we're increasing the reaction rate, right? The higher the temperature, the more it is for molecules to collide with each other. I like to use this example. So, if we had ice if we had iced tea and we have hot tea and we put sugar in both of them, right? And we stir both of them, the iced tea is going to take longer to dissolve that sugar because the temperature is lower, right? And the molecules are kind of moving at a sluggish pace. However, if we have hot tea, right, and we're stirring that sugar in, the sugar is going to dissolve a whole lot faster because the temperature is causing the molecules to move more. And once they're moving more, we have more collisions, right? And more collisions means a faster reaction. Now, number 5, surface area. If we increase the surface area, we have a faster reaction. And what do I mean by surface area? The more of the substance that is exposed, the faster our reaction would be. Another example, if we have cube sugar and grain sugar, and we put them both in our iced teas, right? You'll notice that the cube sugar will dissolve, but inside it's going to take longer to dissolve. But our grain sugar is going to dissolve so much quicker because more of its surface area is exposed. More of the substance is exposed. Because more of the substance is exposed, you have more chances of interaction. And the more chances of interaction means that the more chances of possible collisions, thus increasing the speed of the reaction, thus increasing the rate of the reaction. Right? And the last one, and catalyst is a little different, so I'm going to take my time and explain this one. Catalyst. Catalyst speeds up the reaction without changing the nature of the reactants and products. Meaning, I'm not changing your starting material and I'm not changing your ending material. What I'm going to do is I'm going to lower the energy it takes for the reaction to start. That is what a catalyst does. It lowers the energy in which it takes for the reaction to start. Meaning that instead of it taking 5 hours for the reaction to start, it's not going to take 2 hours for the reaction to start. That's just an example, right? I like to compare this to, once again, the subway system. If you can walk from Manhattan to Brooklyn, you can take the Brooklyn Bridge, right? And it's going to take you so much longer. Or you can take the subway and get there within 30 minutes, right? The subway is our alternative pathway, right? It's just a quicker way for the reaction to happen, but it's not changing the reaction. It's not changing what you're starting with. It's not changing what you're ending with, right? It's just giving you a shortcut or an alternative pathway. And that's just by lowering the activation energy, the energy needed for that reaction to actually happen. All right? So that is it for today. Told you, quick and simple lesson. Make sure you read. If you have any questions, please ask. And I'll see you next time. Have a great day, guys.